All right, all that good stuff I said, none of that got recorded, but that's okay. So we're going to look at the sine, cosine, and tangent of the 45-degree angle. And because a 45-degree angle, right triangle, has this particular relationship between the sides, when I write my sine, that's my opposite. If this is my 45-degree angle I'm focusing on, that's the opposite side over the hypotenuse. But then the adjacent side over the hypotenuse for the cosine looks exactly like that. So that's one of our first fun facts about a 45-degree angle. A 45-degree angle has a sine and a cosine that are equal to each other. And if we simplify these two ratios, if we divide out the x, we're going to be left with 1 over the square root of 2. But we tend to like that in its rationalized form better. And so we're going to focus on square root of 2 over 2. So 1 over square root of 2 is the same as square root of 2 over 2, and that special value is the value that is the sine of 45 degrees. Now, we're not using our calculators, but if we were, see if I can find my emulator. Oh, there he is. Come here, Mr. Keck. Oh, there he is. Okay, so first of all, your calculator can think degrees and radians. The things work a little differently, so I'm going to go ahead and change this into degrees. And so sine of 45 degrees, you might say, well, what gives me that? But if I do 1 divided by the square root of 2, that's that decimal. Or square root of 2 divided by 2. So that's something we have to have memorized. We have to know that the sine of 45 degrees is the ratio, special ratio, square root of 2 over 2. And that the cosine of 45 degrees is exactly the same thing. Can anybody tell me what the tangent of 45 degrees is going to be? If I do opposite over adjacent, Mason? It's going to be 1, right? Because the opposite and the adjacent, that's my 45-degree angle I'm focusing on. My opposite and my adjacent are exactly the same size. X over x is equal to 1. So I have a number for the sine of 45 degrees and cosine of 45 degrees and tangent of 45 degrees based on my special right triangle that I can know without a doubt. I'm never going to ask you like, hey, what's the sine of 37 degrees? Because that's not an easy ratio to know. 37 degrees isn't special, so that you can, it's not easy to have the ratio. You can calculate it, and calculators have the built-in technology, or you can look, the old days we would look it up on a table. But something like a 45-degree angle, yeah, we're going to have to know that the sine of 45 degrees is always the square root of 2 over 2. Or if you want to say 1 over square root of 2, either one of these is acceptable. Sine of 45 degrees, cosine of 45 degrees, tangent of 45 degrees. Questions on that? Now let me add something from our last class. We included 3 new ratios last time. This thing called the cosecant. This thing called the secant. And then, oops, I'm writing the wrong thing. The cotangent. I'm writing the words down again along with their abbreviations. Eventually we'll just write the abbreviations. Now each of these we were going to have to know, but we could relate it back to sine and cosine and tangent. So when I write and I think about talking about cosecant of 45 degrees, the thing that's going to help me answer that question is cosecant is reciprocal of sine. Whatever my sine value is, the cosecant is its reciprocal. It's the flip of the fraction. It's the switching of the numerator and the denominator. So I'm actually going to take it in this form and write just root 2. You could also write, and let me put another piece of paper here. So, you know, this is where we start getting into all kinds of rationalizing things. If we take 2, okay, so if we take another way to think about this, if we take that the sine of 45 is root 2 over 2, and the cosecant of 45 then is its reciprocal, if I rationalize that, this is where my algebra 2 comes in, it gets simplified down to that. Okay. So it's a little tricky sometimes because this and this don't look like they're reciprocals. Square root of 2 over 2 and square root of 2 don't look like reciprocals, but they are reciprocals because if you multiply them together, you get 1. That's actually the definition of 2 numbers that are reciprocals. Their product is 1. It's just how we clean up this answer, how we clean up that reciprocal that we represent it that way. Using the exact same thinking, the secant is just like the cosecant. It's equal to square root of 2 for 45 degrees. And cotangent, reciprocal of tangent, is also going to be 1. Now, if you're thinking like, why is she showing us this? Like, why is she going through all these specifics? Because you're going to have to memorize these. And it's one thing to just say, here, memorize this, which you could do. You could be like, all right, she's going to give me a piece of paper and it's going to have a bunch of stuff and I'm going to memorize it. But it's a lot different, or it's hopefully better to try to memorize something if you understand where it comes from. So that if you do kind of space out and you're like, okay, whoa, sine of 45, I don't remember, how's that supposed to work? The triangle can kind of hopefully help you if you can remember the labels in the triangle, and you know how sine works, then you can kind of go, oh yeah, I remember that's something. Oh yeah, that's the root 2 over 2 one. And that can kind of generate, kind of get your memory back. So root 2 over 2, sine of 45, root 2 over 2, cosine of 45. 1 is the tangent of 45. I want you to focus on those 3 to start. We're going to want to be able to do these 3 also. But if we know these 3, then we can make these 3 by reciprocal. So our focus for memorizing is going to be this first stuff. And I'm actually going to be making us a chart. Okay. So 30 degrees, 45 degrees, 60 degrees, sine, cosine, tangent. This is what I know so far. For each of these angles, for 45-degree family and 45 degrees, the sine is root 2 over 2, the cosine is root 2 over 2, the tangent is 1. We're going to come back to this page, and our goal is going to be to memorize this chart. So that's where the 45s come from. 30s and 60s are actually related to each other. So if we do the 30s, we'll be able to get the 60s pretty quickly. All right, so how are we on the 45s? Are you okay with where I got those numbers? Square root of 2 over 2, square root of 2 over 2 for sine and cosine, 1 for the tangent. Oops. All right. So let's talk about the 30, 60, 90 triangle. And we're going to focus on the 30 angle. Okay. If the 30 side is x, and that's our opposite, our hypotenuse has to be 2x, and our other leg has to be x squared root of 3. So take a minute and write me these ratios. What are the sine and cosine and tangent going to be focusing on the 30-degree angle? So if 30-degree angle is our focus, so x is opposite. Right now, we have like a new hall pass thing that's going to happen, but I have to get that organized first, so we'll just keep writing them. Okay. So x over 2x, x root 3 over 2x, x over x root 3. Remember, this is opposite, hypotenuse, adjacent, hypotenuse, opposite, adjacent. So what happens to my sine of 30? What do I end up getting? X over 2x simplifies down to, if I divide the x's out, 1/2. And square root of 3 over 2. And this is our least favorite one, 1 over square root of 3. which I'm perfectly fine with you writing it that way, but rationalized it would be root 3 over 3. So same story, because a 30, 60, 90 triangle has these special relationships between the sides that are really easy to talk about. It's really easy to talk about the sine of 30 and the cosine of 30 and the tangent of 30 using very nice fraction descriptions. We don't need a whole decimal. If this was a 37-degree angle, this would be a lot different. Sine and cosine and tangents would be different, because this side would be a little smaller, bigger, this side would be smaller, this side would be different. They wouldn't have this nice, really working together combination of sides. So, 1/2 square root of 3 over 2 square root of 3 over 3. And we're going to pay attention here. We're going to have some tricks here for memorizing this. It might be at the beginning that you'll make a little note on your paper and you'll write some things down to help yourself when we're going to use these values. So it might not always be that you're pulling them straight out of your head. You might kind of do a little memory dump. But so if we have a trick for how to memorize what's on this table, so that if we need to, we can just jot a really quick little table on our quizzes and tests, then that's totally fine. So 30-degree, little bit of a different pattern than the 45. If I take the exact same triangle, but I focus on the 60-degree angle, okay, which doesn't change how things are labeled, but if that's my focus, then that side becomes opposite, that side becomes adjacent, and that stays the hypotenuse. If 60 degrees is our focus, across the street is the root 3 times x. So when I write the sine of 60, the sine of 60 is going to be exactly the same as the cosine of 30. This is why 60s and 30s are related to each other, because they're just two different angles in the same right triangle combination. So when I get the sine of 60, when I'm focusing on my 60-degree angle, he is my opposite side, he is my hypotenuse side. I get the same ratio that I got for the cosine of 30. When I do cosine of 60, I get the same ratio I got for the sine of 30. And then the tangent of 60, oops, let's shrink that down a little bit. If I do opposite over adjacent focused on the 60, it gets me just square root of 3, or square root of 3 over 1 if you want to think about it like that. You were supposed to kind of see this happening when you did a bunch of triangles on the homework worksheet that you had. And if you're thinking of what homework worksheet, I'll remind you of that. There were a bunch of different triangles where you had the 30s or the 45s, and then you went through and did the trig functions. And over again, if your focus was a 60-degree angle and you were doing a sine, this is what you should have seen. Or if your focus was a 60-degree angle and you were doing a cosine, you should always get something that simplifies down to that. Okay. So that the third piece of this chart looks like this. Square root of 3 over 2, 1 over 2, square root of 3. Now, patterns help us remember things. Rhythms, sometimes singing things, making up sentences, whatever you do. My trick has always been counting. In this case, looking, if I remember the headings across the top and across this down the side. So 30, 45, 60, sine, cosine, tangent. If you look at my fractions, for sine and cosine, they all have denominator of 2. And it's 1, 2, 3, 3, 2, 1. You've got the roots in there. If you want to write a root over that 1, you can, because the root of 1 is still just 1. And so that might help you. Say, okay, I'm going to write, if I want to write roots on those, I can do that. A root 1 is equal to a 1. So it's root 1, root 2, root 3, root 3, root 2, root 1, all over 2. 1, 2, 3, 3, 2, 1. And then 3, 3, 1, 3. That's not the best one, but I kind of treat it like a phone number. I'm like 1, 2, 3, 3, 2, 1, 1, 3, 3, 3, 1, 3. 1, 2, 3, 3, 2, 1, 3, 3, 1, 3. Sine values for 30, 45, and 60. Cosine values for 30, 45, and 60. Tangent values for 30, 45, and 60. 1, 2, 3, 3, 2, 1. Don't forget the roots. 3, 3, 1, 3. Numerators have the roots. Denominators don't. The tangent row is probably the weakest in my pattern, but I think we can make it happen. If we know these, if we know this is going to be big. It's going to take us into a lot of angles. We are going to be able to write sines and cosines and tangents of lots and lots and lots of different angles without a calculator. We're going to be able to also then come up with cosecant, secants, and cotangents of lots and lots and lots of angles without our calculator. But we're not going to be able to do any of that if we don't memorize this first set of relationships. 1, 2, 3, 3, 2, 1, 3, 3, 1, 3. Okay. I'll give you even one more trick. Tangent actually always ends up to be the sine over the cosine. So if I want tangent of 45, if I put the sine of 45 over the cosine of 45, that will give me the tangent. Now, sometimes those aren't pretty to reduce, and that's why a lot of times we just learn the tangents separately. But if you got in a pinch and you forgot, root 2 over 2, root 2 over 2, 1 over the other equals a 1. This fraction over this fraction will simplify down to that fraction. Sine over cosine also equals tangent. That's another relationship we can use. So, you're going to have this chart memorized, okay, so that let me throw a blank page in here real quick. Oops, hang on. All right. That questions like these, when I throw these out and say, okay, tell me what these numbers are, these are not type in your calculator questions. These are use what you know, use what you're memorizing from your table. So a 60-degree angle's cosine is a half. And a 45-degree angle's tangent is 1. And a 30-degree angle sine is also a half. And then I can start doing things like this. And you're going to have to use, oh, well, this is the reciprocal of the sine. And my sine for 30 is a half. So the cosecant of 30 is 2 over 1, or 2. This is a really tough part of the course to kind of get students to be on board with. Because when you watch me answer these questions, it doesn't look like I'm doing anything. But what I'm doing is referencing this set of relationships. Okay? You need to learn this set of core relationships. From this set of core relationships, a bunch of other answers are going to come, but only if you know this. If you're auditory, like I am, so that's probably why I'm saying, that's why I like 1, 2, 3, 3, 2, 1, 1, 3, 1, 3. Me saying that helps me know how I would write it down. Some of you are going to be visual, and so maybe you picture this and you remember, you're like, okay, if I can just start here, if I remember that corner, I can fill out the rest of it. What you should be doing for homework to practice is doing stuff to help you memorize this. So maybe you do this. All right, you write down your angles, you write down the functions, and you go, okay, let me see if I can do it. If that's a half, that's that. Or maybe then you go down and you're like, okay, and that goes here and that goes here. And then we got to do, it's what, 3, 3, 1, 3? Whatever you need to do to be able to do that, just like I did it. And come on, I have an old brain with old brain cells. I can't remember, my glasses are on my head sometimes, but I can still remember that. You have a young brain with young brain cells with still room in there. You can learn dances and lyrics and all kinds of other stuff. You can memorize this. I don't believe there's anybody in this room that cannot memorize that if they decide to. So you decide, memorize that. That is your homework. Memorize that chart. So that if I gave you a blank chart and said fill it in, you could do it. As quick as I did it. Not thinking and not, you got to be able to do it like that. Okay? That's your homework. The other assignment you had over